Today we'll be taking notes over waves. This begins our unit in physical science. If you are at school, you will be filling out the template, and I'll show you how to put that into your notebook once we are done. If you're not in school, absent for any reason, quarantine, illness, unexcused, then the expectation is that you are still writing these notes in your notebook. And I'll let you know what you need to write down and any images that you need to draw in your notebook. Then at the end of this assignment, you'll take a picture of your notes and submit this on Schoology to get credit. Now remember, the expectation is that you're writing these notes in your notebook, whether or not you're in class. This is our physical science unit, the beginning of our physical science unit. We're not reviewing any material. This is new information. And you need to make sure that you get your notes in your notebook. You will have a unit test at the end of this unit. Okay, so let's start our notes. Those of you in class, you will follow the template and fill in the information. It's written in blue. Now, if you're at home, you're going to need to, again, write down what's on the slides. So we're going to start with what are waves and the definition. Waves are a temporary disturbance that transfer energy from place to place. Go ahead and write that down. And here are some examples of waves. You will not need to write down these examples. If at any time you need to pause this video so that you can write down the information, that's fine. Okay, we're going to move on to mechanical waves with its definition. Mechanical waves are waves that need matter, a medium, to transfer energy. Examples are waves in water, and sound. You will need to write this information down in your notebook or on the notes. Here's a couple of pictures. You won't need to write that down. You can see how they move through the water, the waves are going, and then sound can also travel through water with echolocation. Okay, matter used. That is a medium, is a material that a wave travels through. You'll write down this slide. You won't need to draw the pictures or anything. Types of mediums. You'll also write down this information. Solid, liquid, gas, air, water, particles, strings. Although waves travel through a medium, they do not carry the medium with them. You don't have to write that down. And here's an example slide of that. So remember, waves don't carry the medium with them. And an example of this is when the wave travels under the duck moves up and down, but the duck doesn't travel with the wave. After the wave passes, the duck and the water return to where they started. So that's what we're talking about. As the waves move, they don't necessarily carry that medium with them. They just travel along. Like it's a disturbance in that water. You did not have to write this information down. Okay, if you're in school, you're going to open up the notes. There's two types of mechanical waves. We're going to start talking about the first type today and take notes over that, and then the second type tomorrow. The first type is going to be transverse waves, and you need to write this definition down. If you look in your notes, it says transverse waves and definition. That's where you'll write this down. Transverse wave is a mechanical wave in which energy causes the matter in the medium to move up and down or back and forth at right angles to the direction the wave travels. Even if you're at home, you need to write that down in your notebook. You will need to know that definition. And in your mind, when we talk about waves, this is probably the image, a transverse wave. That's probably what you think about. An example, waves in water. Go ahead and write this down. So here's a picture of a transverse wave and then motion. So they have this rope tied to this little ring over here, and they're moving their hand up and down to cause those waves in the rope. These waves move at a right angle. Okay, the transverse wave parts that move up and down. In your notes, this is going to be to the right of that sheet of paper. If you're in your notebook, just write this down if you're not in school. The crest is the highest point of a transverse wave. Trough is the lowest point of a transverse wave. In the image, in your notes, you can go ahead and label those, but you also need to write the definitions down. The frequency of a wave. Frequency, and you'll write this in your notes, the number of waves that pass a given point. And these are examples of high versus low frequency. You'll need to draw these in your notebook and label them. This first wave is an example of a high frequency wave. More of these waves are going to pass a given point than of the low frequency wave that are more spread apart. You want to make sure you make note of this information over here. Write this down in your notebook or in your notes. They are measured in hertz. Hertz is symbolized with a capital H, lowercase c, and it is equal to the number of waves per second. And you'll use this later on in the formulas that we learn. Okay, 2 wave properties. Wavelength is the distance between 2 corresponding parts of a wave. You can see that they're taking the wavelength. The corresponding parts are the tops of the wave right here. And then amplitude is the height of a wave when viewed as a graph. The wave's amplitude reflects the wave's energy. You need to write both of this information down. And here's an example. This wave doesn't have very much energy, low amplitude. You can see the wave is very low to that starting point. This wave is going to have increased amplitude, increased energy, and down here we have the highest amplitude and the wave with the highest energy. Okay. Now, if you are at home, you'll take a picture of this and post it on Schoology. If you're in the classroom, you're going to cut out the template. Now that you've finished, and you'll keep the trash with you. Just throw it away when you're dismissed out of class. Everything should be completed and filled out. This was the image of the transverse wave. If you did not label these, go back and label them correctly from the definition. You will use the words on the right side of your notes. And again, this was just the transverse waves that we were covering today. We will look at the second type of mechanical waves tomorrow. And then we'll have a lab over these waves later on. Now to construct this, you're going to take the top part that's got that image on it and where you talked about the waves, and all of this should be completed. And you'll glue along the tab, and you want to just use a little bit of glue. To glue this down.
So not a lot. My blue's invisible, so you can't really see it, but if you could, there's not a lot on there. Just match that up and lay it on there. And that way, should I match up? That way you can lift the top to see the inside where you've labeled the transverse wave, where you have written all these definitions and information about a transverse wave. And then this will go in your notebook on page 48. It says on the back to glue this down. Just a little bit of glue, not a lot. Again, mine's invisible, but there's not a lot on there because I want this to be able to open up later on. You can just set that right in there. And then you're done. Now, if you were at home, you wrote the information on here and you're going to take a screenshot of this and submit it on Schoology.